Hello, guys. Welcome back to MedZone African Motives. In this case, we are going to consider this part as a separate class on its own. We are going to look into the functions, but the major part that we are going to look into is to determine the value or values of x. It can be the value or values of x depending with the part that you be given in terms of the question. So this part must be done graphically. We are to determine the values of x graphically, meaning to say we are to use the graphs, the information that you are given graphically. Remember, we had inequalities before where we had to solve those inequalities. All right, remember before. But this time we are not to solve that. We are to use the graphs. All right. So the first concept that we are going to look into is the type of questions of this nature where you are given a certain function, then you need values for that function to be greater than zero or to be greater than or equal to zero, or we can have a condition where that function is less than zero. So we are going to look into that one separately. So for you to understand the typical questions that you are going to be given, make sure that you follow the playlist, all right, up to the end that is following the videos, as we are going to have them according to how they ask, all right. The major part is what is important on how to attempt these typical questions. All right, so like I said, guys, before we were used to a certain, given a certain quadratic, all right, because this is from our functions, it can be any function. Let's consider a quadratic as we are used to before. You were given something like this: x squared plus 5x plus 6 as your quadratic, right? And it is given that it is greater than 0, it is greater than or equal to, it can be less than, it can be less than or equal to. How were you to solve this? You were going back to the factorization concept. It was not a graph, it was just a question: solve for x. All right, you were just given that. Solve for x. So from there, you have to determine the critical values first by your factorization. All right, this is x here, this is x, considering the factors of 6. All right, so here I'm just going to rush as we are used to this. So what are the factors of 6, which adds up to what? To 5. So the factors of 6, which adds up to 5. All right, 6, there's a product. All right, all right, all right. Let's see, let's see, let's see. I was supposed to put the 6 here, sorry. The 6 here and the 5 here. Sorry for that. I just want you to consider just a basic one, all right? This is a basic one. Do not worry about that. So the products of what? 5 in this case. So that will add up to 6. So we've got 5 and 1, -5 and -1. As we can see, the sum is supposed to be positive. So we're going to focus with what? 5 and 1. So you're going to add that 5 here and 1 here. Then you determine your critical values, which I said it is just like you are solving an equation where you are taking the two brackets, the bracket of x plus 5 and the bracket of what? X plus 1, equating it to 0. You're no longer focusing to say, all right, is an inequality. You take it as an equation where you are going to equate each bracket to 0. That's going to get a -5 on the other side, or x is equal to what? -1. A positive is going to be -1 there. So those were going to be your critical values, where x is -5 or x is what? -1. So I want us to consider what we are referring as the critical values, because those are the ones that we are going to now finalize to say, all right, what will be our solutions? So it's either you're going to use the number line or you're going to use the graphical concept. So I want us to explain, I want us to have this explanation on a graph because all of this part is supposed to be done what? Graphically. But I just want you to have a basic of where it is coming from. So on your graphical concept, you're going to have, all right, this is your x-axis, which is the major part. Whenever you are to solve for what? For x. Here, determine the values of what? Of x. We are not focusing with the y values. We are focusing with what? The values of what? The values of x. So for the values of x, it means what is important, it is what? The x-axis. This is the major important part, the x-axis. So for these values, you're going to indicate, all right, -5, where you're going to get -5, you are going to indicate -5 and -1. -5 will be somewhere here and -1 here. Then you consider, all right, what is the shape here? Since the coefficient of x squared is a positive, is 1, so we are going to have what? Concave up, meaning to say we are going to have something like this. Then you now compare to say, where do we have this? And you're saying it is what? Your f of x greater than 0, comparing to the x-axis where y is equal to 0. You consider now those critical values to say above what? The x-axis. Our solutions are supposed to be above the x-axis, greater than 0. So you're going to take these solutions, all right? This side and this side. You're going to consider to say that x is what? Less than -5. We do not have an equal to on our solution, on our question, so we're not going to have it here. We are not going to have that one. Or x is what? Values which are greater than what? -1. So I want us to go back. I want us to go back here. You were indicating or you were representing your function like this. This part x squared 6x 5 like this whole part, it is representing our function f of x. This is our function f of x. This is our function. So in our case, we have already this sketch of our f of f. They will be giving, we will be having that, or maybe have already drawn that sketch. Then they're asking you now to determine the values of x for which f of x is greater than 0, for which f of x is less than 0, depending on the question. You are not going back to the solving like this, where you're gonna need critical values, this and that. Already the values of x you'll be having, unless if these values of x are not there, then you must consider what? Finding them. So what we can see here is that the critical values, the values that we are saying x is equal to -5, x is equal to -1, they were taken from a condition where f of x is equal to 0. And what is that condition? It is the condition of determining the x-intercepts. So in our case, what we are referring to as the critical values for this type of equation, where whether it is f of x is greater than 0, it is f of x is less than 0, whatever that you're given, your critical values are the x-intercepts. This one, they represent x-intercepts. Those are the ones that you're saying are your critical values. So what is important is for you just to note what are the x-intercepts. This is the major case. What are the x-intercepts? Then you compare from those x-intercepts according to the question. If it is that f of x is greater than 0, you look above the x-axis. If it was below, then it is f of x is what? Less than 0, where your solutions will be below the x-axis. That is the condition. What is important there are the x-intercepts. Then you compare with the x-axis to say, what is it that I'm having? Below the x-axis, less than 0. F of x it is like y is less than 0. This is where y is equal to 0 in the x-axis. So where y is less than 0, it is what? Below. F of x is y is greater than 0. We're talking about above what? The x-axis, where y is equal to 0. Above. So using this, we can answer questions now graphically for any function that we are given for this nature. So we are going to consider to say, for this nature, what is important is that our critical values, they are represented by what? The x-intercepts. Those are the what? X-intercepts of what? Of the given function. If it is gx, if it is f of x, the x-intercepts or the x-intercept when it is maybe you're talking about a straight line. For a logarithmic graph, for an exponential graph, it will be just having one intercept, x-intercept. You compare from there. You compare from there. So your critical values is what? The x-intercepts. So after knowing your x-intercepts, what is it that you're going to do? You compare with what? The x-axis where y is equal to 0. So that will be your final solution. So you compare with the x-axis. Compare with the x-axis. This is for what? For solutions, all right? For solutions, you are going to compare with the x-axis. As in the x-axis, that is where y is equal to 0. Remember, we are comparing to 0. Each and every part there, whatever that way is compared to what? To 0. That is what? The x-axis. So you compare from there. That is taking what? The final solution. Okay, so this is what I'm trying to say. Let's say we have got a function. All right, I'm just gonna have something like this. This is our x, this is our y. That's a 0 like this. And this here is a straight line. It is a linear function, a straight line like this, right? And this point was what is important, the critical values, the x-intercept. So as of a straight line, the x-intercept is we're just gonna you have one x-intercept. Let's say it is 2. This is the value of x at this point. X is equal to 2. So the comparison is done at that point, at the x-intercept. For the given line, y is equal to mx plus c, whatever that you're given. The comparison, whatever comparison that you're going to have, let's say this line represents the graph of what? The graph of f. If the question was to determine the values of x for which f of x is greater than 0, let's start with that one. Greater than 0, remember the critical values, x-intercepts. So in the x-axis, the part that is important in the x-axis is what? The x-intercept, which is at 2. So we compare now with this x-axis for solutions to say, when it is f of x is greater than 0, it means above what? The x-axis. Y is equal to 0. So greater than 0, we're talking about values above the x-axis. And as of the straight line, at the point 2, from this side, going this, as you can see, the graph is above what? The x-axis. From the point 2, going 3, 4, 3, 4, and so on and so on. 3, 4, 5, and so on. The line or the graph that we are having will be above the x-axis, on top of the x-axis. This is on top. X-axis is what? Is below. So all these values. So therefore, our x is going to be what? Greater than 2. The critical value is 2. The x-intercept. This is our critical value. So x will be greater than 2. Just like that. If there was an equal to here, your answer also must have an equal to. That is what it means. You also consider the type of the function that you're having. It is not always where they put an equal to, then also you put an equal to, because remember, some graphs, just like a hyperbola, they have asymptotes where x cannot be equal to that value. So you also compare with the type of the graph. But as for this one, when there is a less than, when there is a greater than, whatever that you're given, you also put it on your answer. So if there was an equal to, you must also put it there, but we do not have that. So that would be our solution, where f of x is what? Greater than 0. So meaning to say, if the question was to ask us the values of x for which f of x is less than 0, meaning to say it is below the x-axis. So in other words, here it is just where it is positive. All right? When it is less than 0, where it is what? Negative. Below the x-axis. So you compare from the x-axis. From what? The critical value 2. From this point, that is where we're having our comparison at 2. So at 2, we can see that going to the left side, the graph here is below the x-axis. This is our x-axis. And our graph is found below. The x-axis is what? Is above of the graph. Our graph is below. It is negative. It is below the x. So the y values, they are what? They are negative. Starting from that, 2, 1, 0, and so on. The values will be what? Negative. So therefore, in our case, x is supposed to be what? These values, 1, 0, minus 1, minus 2, all these values that we are having going to the left, they are what? Compared to 2, our x-intercept, our critical value, they are less than what? They are less than 2. So this is our condition. So for any value that we take that is less than 2, our function is what? Our function is a negative. So that is how you compare. So it depends now with the graph that you are given, all right? Is the parabola that you're given, is it a hyperbola? Is it a logarithmic function? You can even be given a logarithmic function, all right? Something like this. Remember, a logarithmic can be increasing or decreasing. Let us just take something like this, all right? Which is having the x-intercept at 1. So let's say this is our f. We compare from that, and remembering that in our case, the y-axis is what? Is an asymptote, where x is equal to what? Where x is equal to 0, meaning to say x can never be equal to 0. We are talking about values of x being greater than what? Being greater than 0. All right? So let's say the question here is asking us from this function, the values of x for which f of x, all right, is greater than 0. Or it can be greater than or equal to 0. For which f of x is greater than or equal to 0. So we just compare our f with what? The x-axis, where y is equal to 0. What is the critical value? The critical value is what? The x-intercept, of which we have it, x-intercept. So this is where we are having our critical value. From this critical value, you can compare, because we've got two sides. It's either we're comparing to the left side of this one or to the right side. So as we compare to the left side, what is happening? The graph here of f is below the x-axis. This is our x-axis, remember? It is below. This is our x-axis. From this one, going this side, it is below. The graph that we are having here is below the x-axis. This is not what we want. We need a condition where f of x is what? Positive. It must be above the x-axis. So that is from 1. Going this side, you can see our f is above the x-axis. It's on top of the x-axis. It is positive. Here it was what? Negative. So where it is positive, those are the values of x from 1 going up, 1, 2, 3, 4, and so on. So x will be greater than what? Greater than 1. But since we have an equal to on our answer, it means x can be greater than 1 or equal to 1. The critical value is also part of your solution when it is like that. All right. So you must be very careful. And let's take note about this one. Let's say they wanted a condition. All right. Number two, let's say they wanted a condition where f of x is less than or equal to 0. Meaning to say it must be what? Negative. And the negative region is this one. This is the negative region where the x values compared to 1, the critical value, they are going this side to the left. They are less than 1. So our x values for that condition, it was supposed to be x is less than. It was supposed to be x is less than what? X is less than 1. Here, like this. X is below than 1. But we cannot just leave it like this because remember that the y-axis is the asymptote. X is equal to 0. The graph is limited. It cannot reach the y-axis. It cannot reach the line x is equal to 0. In whatever that is going to happen, it cannot reach there. Here it can have a condition where it is less than 1 because we've got an equal to here. We can also, it is what? Equal to 1. But as for 0 now, as we are going to the left side, we cannot even have negative values such as negative 1, negative 2, negative 3. We cannot have such values. From 0 going, we cannot have that. So it means we are limited to say the same x that we are saying it is less than or equal to 1, it must be greater than 0. It must be a value bigger than 0. It cannot go beyond that. Because of what? The asymptote now. So you answer the question according to what you're given. You must be very careful in answering of the question. How do you answer your questions? All right, so that is the basic view. We're not gonna waste your time, guys, because this one you had it from your grade 11, actually from grade 10. Grade 10, you've been working with such questions, so I'm not gonna waste time. But if you do not understand or there's a part that you have, remember the community section is there. Send your question on the community section. Do not waste time or bother to use the WhatsApp, and it's best that we use that community section on the YouTube as it is. It allows you even to take a picture. All right, you can take a picture, post it there, ask your question exactly what you want to understand. You can even copy a link of a certain video where you do not understand and paste that on the community and ask exactly using the timestamp. Say at this time, how can we have this? Or maybe you've got your own way. You can take a picture and show us how exactly you were going to attempt that question. So guys, the community section is there for you. Utilize it in as much as you can. All right, so without wasting our time, because we're going to look into this question, before we check that, let us just add one or two on a quadratic function, because most questions they will be on a quadratic function. Let's say we are given something like this. This is our f of x, all right, that will be given Cartesian plan. Then we have got f of x, something like this. It was already drawn for you, all right, something like this. This is your f with the x-intercept at -3 and at +4. All right, those are the x-intercepts. Then the questions can just be given anyhow. All right, let's say we want to determine the values of x graphically for which, all right, for which number one, f of x is greater than 0. F of x is greater than 0. So like I said, whenever you're given this type, you must know your critical values, all right? In which our critical values are the what? X-intercepts. So we compare with or from that using the x-intercept to say the x-intercept, they're already there. 3 minus 3 and what? And 4. Those are the x-intercepts. So it divides now our graph into portions. All right. From those, we have got 3 regions that we are going to use. This region, this side of -3, in between -3 and what? And +4. And these values on the other side of 4 like that. So meaning to have got 1, 2, 3 regions. Where is that our function is greater than 0? Where is that our function is what is positive? That is the condition, just like that. All right, so let's consider from -3 going this side, our function compared with the x-axis, we can see that it is above the x-axis. It is on top of the x-axis. The function is above. So once it is found above the x-axis, it means it is what? Positive. Then in between -3 and 4, the function, this is our function, it is below the x. As you can see, it is what? Below. So we cannot take that one because it's a negative. And from 4 going up, our function, as you can see, it is found on top of the x-axis. So it is above. That is what? Positive. So, and this is exactly what we want. So the solutions are going to be taken from this region and this other region. So therefore, in our case, we are saying that x is what? Values going this side of x. You're comparing x now. You're taking the values for x. -3, -4, -5, -6. How are they compared from -3? X is less than -3. We don't have an equal to here, so don't put it on your answer. Another set of solutions is taken from 4. These are the x values from 4 going up. 4, 5, 6, 7. Compared from 4, we are saying x is what? Greater than 4. So these will be our solutions where f of x is what? Greater than 0. So if there was a greater than or equal to, you're just going to put equal to here. That is it. All right. Let's consider a condition when it was less than, where it is less than, all right? So where f of x is less than 0. So when it is less than, that is below what? The x-axis. And this is the region where it is what? A negative. So you can see between what? -3 and what? -3 and 4. It is below the x-axis. So x is greater than -3, but less than what? But less than 4. We do not have an equal to, so don't put it. If there was an equal to, you're going to also have it on your answer. But in this case, we do not have. So that is how our solutions can be like. We just have to be very careful. All right, so without wasting your time, let's consider a typical exam question. I just took a part of this of this type of a question where we are explaining. So it was actually from June 2024, question 5 of the Free State Province. So I'm just going to take this part. It was sketched below. It was a parabola, and we had a lot of questions, but I just want to focus on what? Question 5.4, which was for which value or values of x will f of x be less than or equal to 0? Will our f of x, and this is our f of x. So according to our f of x, you were going to actually find the critical values as I said, f of x, as long it is compared to 0, it is just f of x here. As long it is just f of x, your critical values are the what? X-intercepts. So you're going to determine the x-intercepts, all right? Which is, you are going to solve this when it is equal to 0, all right? Which was part of your questions. I'm not going to focus on that one. So here, our A was going to be 1. It was 1. And C, it was 3. Those were the x values. So meaning to say we have got the critical values where x is 1 at A and x is 3 at what? At point C, as we are talking about the x-intercepts from what? From our x-axis. So where is it that the whole function f of x is what? Less than or equal to 0? It is what? A negative. When we say it is a negative, it is what? Below the x-axis. So from A, as we can see, going to the left, this function is what? Negative. It is below the x-axis. It is negative. We are comparing from the what? From A. Then between A and C, between 1 and 3, the function f of x is above the x-axis. You can see it is found on top of the x-axis, meaning to say it is what? Positive. From 3 going down, from 3 going this side, 3, 4, and so on, the function is found what? Below the x-axis, meaning to say it is what? A negative. So exactly the points that, the positions that we want, where it is below the x-axis, where it is less than 0, we are comparing from what? From 1 at A, so meaning to say x must be less than 1. 1, 0, minus 1, minus 2, and so on. So x is less than 1. We have an equal to on our question, so we must have equal to here. Or another one, where it is negative, we saw that from 3 going to the right, 3, 4, 5, and so on, the function is found below the x-axis. It is what? A negative. So from 3 going up, these values are greater than what? Are greater than 3. Since we have an equal to there, our solution must have an equal to again. So these will be the two solutions which satisfy the inequality where f of x is less than or equal to 0. Just like that. So the opposite, if it was a condition where f of x is above, greater than or equal to 0, we are talking about where it is positive, above what? The x-axis from A to C, in between this position. Our f of x is what? Above the x-axis. So x must be greater than what? A, which is 1, but less than what? But less than 3, in between 1 and 3. All right, but because there's an equal to, we must also put that equal to on our solution. So if it was like this, then this will be our solution. What is important are the critical values, which are the x-intercepts. All right, so we are going to meet again in another class. Like I said, please follow the playlist up to the end so that you can see how do they ask these questions. They can be comparing two functions, f of x and gx. It can be the f of x to its inverse. It can be f of x to its derivative. It can be f of x to its second derivative. So all those typical questions about that that you determine graphically, I'm going to place them in a single playlist. Make sure that you follow it up to the end. And do not forget to join membership if you are new, so that you do not miss any of the other classes that you're going to have. Joining membership allows you to watch anything that is from that level that you have joined, going down any video that is available for any subject. All right, so you join once, then you see all the videos according to the level that you have joined going down. So this is it, guys, till we meet again.